Hello everyone, welcome back. So today we'll be talking about a different model. So we'll start from where we had left in the previous video. So in the previous video we had talked about your semi-log models and particularly about your log-lin model. Okay. So today we'll talk about the second type of your semi-log model, that is your lin-log model. So I'd explained what is the difference between log-lin and lin-log in the previous video. So in the log-lin model, basically your y variable was in the log form while the x variable was not. And in the lin log model, your x variable will be in the in the log form while your y variable will not be. Okay, so this is the difference. So let's see what this model does and what are the benefits of this model. So I hope you remember the previous uh, video where we had discussed the log-lin model, and we saw that your beta 2 was representing the relative change in your y variable for a absolute change in your x variable. So this is the opposite of that model. So in here we'll basically be getting an absolute change in the y variable for a relative change in the x variable. Okay, so this model is used for getting the absolute change in the y variable for a relative change in the x variable. Okay, that is the use of this model. So it is of the form. So we can easily compare this with your previous model, which was like this. I hope this is visible. So this is your lin log model. Your y variable is not in the log form, while your x variable is in the log form. Okay. So this is the kind of regression equation that represents your lin log model. Okay. So the important part here is to understand what is the interpretation of your beta 2. So add so we had already discussed this, what beta 2 is going to tell us here. From here, the first definition that we read, so basically it's going to represent the absolute change in the y variable for a relative change in the x variable. This is your beta 2 and this is what it is representing. So if you want to find this, you can just differentiate this. So if I have to differentiate, so del y by del x is equal to beta 2 upon x. Okay, so this implies beta 2 is basically your del y by del x into x. Okay, so if you rearrange this, you will get this. Okay, so this is basically representing your, or beta 2 is basically representing a change in y in the y variable for a relative change in the x variable. I hope this is understood. So you'll have to see this video in relation to the previous video, and that is how your understanding will be better of this model. So this is a very simple model. So if you have seen the previous video of the log-lin model, so this is going to be very easy for you to understand, right? So we know what beta 2 is. So if I write delta y in this form, okay, this is also just a manipulation of the previous equation. So what is this saying? It is saying that the equation states that the absolute change in y, that is delta y, okay, is equal to slope times the relative change in x. Slope times the relative change in x. This is the slope coefficient and the relative change in x, that is delta x upon x. So if we multiply delta x upon x by 100, this gives the absolute change in y due to a percentage change in x. So if I multiply both the sides, or both the sides both the denominators of both the sides by 100. So this becomes beta 2 upon 100, and this becomes delta y upon delta x upon x into 100. So this thing is basically representing your percentage change in x. Okay, so it means that beta 2 upon 100 is basically implying that it is representing the absolute change in x, sorry, change in y for a percentage change in x. Change in x. So if you uh, see a equation, a regression equation with all the coefficients given, okay, so how do you interpret the coefficient, especially your beta 2? Okay, so you'll divide beta 2 by 100, okay, whatever uh, coefficient is associated with the x variable in the regression equation that you have estimated. So you will divide that beta 2 by 100, and then you will say this, that for a absolute change in y, for a percentage change in your x variable. So whatever change you have, whatever percentage change that your that is happening in the x variable, it is reflecting in beta 2 upon 100 change in the y variable. So this is the absolute change. Okay, so I hope this model was clear. So try to just see the video multiple times if there's any problem. So I'm really sure that you'll be able to understand, because it's not that difficult. And try to see the previous video also on the log len model. So the videos are in two parts, part 1 and part 2. Try to see both the videos, okay? So that's all for this video. I'll see you soon in the next video. Till then, take care.